Hello beta, good afternoon everyone. So today we are going to take ISI PEA 2006 question 4 to question number 6. Question number 4 to question number 6. We have already covered question 1 to question 3 in the last lecture, and you can go ahead and have a look at those questions also. Okay, read out the question beta. So what you can go ahead and you can see, first of all, try to understand that this function, but this function is written in absolute values, right? You see a mod here. So if I were to go ahead and ever plot this function, I know that whatever answer I would be getting the answer only in this quadrant. Whether I put positive x or negative x, I will always be getting a positive answer. I will never go in the third or fourth quadrant. I will always be in the first or second quadrant. That's the first thing that you have to understand. Now, the second thing that you must go ahead and you must understand in this case is that, if I want to go ahead and I want to plot this function, so try to understand this thing. Whether the function increases, decreases, increases, decreases, it cannot go below this axis. Right? So let us try to understand where this function cuts this axis, right? So for that, I need to find out where my function is becoming equal to 0. So we need to go ahead and we need to understand at what point my function goes ahead and it becomes 0, right? And how can I go ahead and do that? Just equate this to 0. So wherever this inside one is going to be 0, that is where your function will be 0. So if you see this, I have half x square minus mod x equal to 0, right? So I will get half x square minus x equal to 0. I'm opening mod x as long as x is positive. So this will give me x half x minus 1 equal to 0. So this will give me either x is 0 or x will be 2. The other way in which I can go ahead and I can open up mod is going to be half x square minus, so instead of mod x, I will write minus x equal to 0, and I will say for all x negative. So I will get half x square plus x equal to 0. So I will take x common, half x plus 1 equal to 0. So either x will be 0 or x will be minus 2. So from here, I have got 3 values of x. That means my function gets a value 0 whenever x is 0, whenever x is minus 2, or whenever x is plus 2. At these 3 points, the value of my function is going to be 0. Now, what can I imagine out of this function? So it can happen that this function can go ahead and it can maybe go ahead like this. Come like this? No. Why? Because I need to make sure that it is going ahead and becoming 0 here, right? So whether it is coming from here or here, it must approach 0. At the same time, I'm pretty sure that at plus 2 also the function is 0, and at minus 2 also the function is 0. It has to be 0 here, right? And in this aspect, it cannot go below this because it cannot go in this quadrant. So it must increase. It cannot go like this because it is no more 0. It's 0 only at these 3 points. So therefore, this function must increase, right? Are you understanding it? Similarly, the case here, it cannot go below here because it cannot turn negative. It cannot go here because it cannot be 0 at any other value. So it must go like this. Are you getting it? Right? Okay. So therefore, what I know is, and same is the case here, beta. You could have argued that, ma'am, it will go like this and then become 0. That's also not possible. It cannot go negative. It's in mod. So it has to be on the positive side and then come back to 0, at 0, right? Similarly, the case here, it cannot go like this. It cannot go and become negative. That's not possible. It has to be there on the positive side only. So we notice that the function goes ahead and it takes the value 0 at 3 aspects: when x is minus 2, when x is 0, and when x is plus 2. At all these 3 points, the function will go ahead and will take the value 0, isn't it? So we can go ahead and say now that the function is decreasing here, definitely, then here, then here. At these 3 aspects, I see that the function is decreasing, right? I can just, here, maybe there will be some local maxima, and these will be the minimum points because it cannot go below 0, right? So this is where it attains its minima. So we notice that the function is decreasing 1, 2, and 3. So we can go ahead and say that it is going to be 3. Right? Okay, beta, come to the next question. Okay. So this says that for a real set of numbers x1 to xn, the root mean square is given to you as summation xi squared by n under root, right? And it's a measure of central tendency. If AM denotes the arithmetic mean, then what's the relationship between the two? Okay. In order to go ahead and understand that, what you can go ahead and do is you can use the concept of variance first. So what is variance, beta? The variance of any number can be written as E of x square minus E of x whole square. Isn't it? Right? This is the variance of any number. And we know that this is nothing but E of x square. And what is E of x whole square called, beta? E of x is nothing but arithmetic mean whole square, right? And we know that whenever we talk about variance of any number, the variance of any number, it must be strictly positive, right? And if variance of any number is strictly positive, then we know that E of x square minus AM square will be strictly positive, right? So we know that E of x square will be strictly greater than AM square, isn't it? E of x square will be strictly greater than AM square. And what is the expected value of anything, beta? The expected value of anything will be summation x square by n greater than AM square, right? And now what you can do is you can just find out the under root, right? And when you will go ahead and you will find the under root, then this will be root mean square greater than AM. So you have proved that the root mean square is going to be greater than the AM. Okay, so this goes ahead and this says you have fx is a function given to you, and it says that let change in f be the function which is equal to f of x plus 1 minus f of x. And then this says this is equal to, okay. So ideally, shouldn't this be the case even with the general derivatives? That if you have to find the kth root, right, then you will find the k minus 1th derivative, and then again you will find the derivative, you will get the kth derivative. Isn't that exactly what we go ahead and we do, right? So it is telling us that, when you have to find the derivative of this number, so actually if you see, this is just the derivation of, the meaning of derivative also, that you're finding the value of the function at x plus 1 and then you're subtracting the value of function at x, right? And here you're finding the k minus 1th derivative, and then again you're derivating it to get the kth derivative. So if I were to find the second root, for example, what will I go ahead and do? I will first find the first root and then I will just differentiate this again. So even this aspect actually goes ahead and makes sense, right? So if I were to go by that definition, therefore, what will happen in this case, beta? We will go ahead and we will have to see. So let's find out the second root first. Let's try to see what happens in that. So if I just go ahead and I find the second root, what will I get? This. And this part it can be replaced with this. So I will go ahead and I will get and then I can just bring change here, right? So when I had to find the derivative of f of x, it was giving me this. So if I have to find the derivative of f of x plus 1, that means instead of x, I have to replace everywhere with x plus 1. So what will this give me? And derivative of f of x is given to me like this. So this will go ahead and this will give me this. So what will I go ahead and I will get? This. Okay. Now let's find the third derivative for once. So I will put the second derivative from here. Right? So what will I get? Right? So if I have to find the second derivative, so here x will be replaced with x plus 2. So I will get x plus 2 plus 1, x plus 3. And here I will get, instead of x, I will go ahead and put x plus 2. There's the negative sign. And then I will put this value. I've already found out this value here. This value. Plus, I will put this value. This value I already know. Which is this. Right? So if I solve this, what will I go ahead and what will I get? Minus 2 plus 2 plus f of x plus 1 minus f of x. So if I just open this up, what will I go ahead and get there for beta? F of x plus 3 minus 3 f of x plus 2 plus 3 f of x plus 1 minus f of x. Right? I will get this. I will get this. Okay, now we need to evaluate what each of this is saying. So I will take this one. So kth derivative, I will take the value of k as 3 first. Right? And I will look at the first one. So if I look at the first one and I'm going till k equal to 3. So this gives me summation I from 0 to 3 minus 1 to the j. This is j, huh? Minus 1 to the power j kj f of x plus j. So if I just open this up, I will get minus 1 to the power 0 k 0 f of x plus 0 plus minus 1 to the power 1 k1 f of x plus 1 plus minus 1 to the power 2 K2 f of x plus 2 plus minus 1 to the power 3 K3 f of x plus 3. Right? Is it making sense? This is what I will go ahead and I will do. Right? Let's try to open this up now. Let's try to open this up. So I need some space here. So if I just go ahead and I open this up, so this will give me k factorial, 0 factorial, k factorial. That means 1. This is just f of x, and this is anything to the power 0 is 1. So from here I will get f of minus 1 to the power 1 will be minus 1. Kc1 will be k factorial, 1 factorial, k minus 1 factorial. It will give me k. For us, but a k is 3, so I can actually plug k as 3 everywhere. I can plug k as 3. Look at the second term now. So 3c1, that means that gives me 3. So k is 3. F of x plus 1. And then plus minus 1 square is 1 into 3c2 again gives me 3. F of x plus 2. And then plus minus 1 to the power 3 will be minus 1. And then 3c3 is 0. F of x plus 3. This is going to go ahead and this is going to give me finally answer as f of x minus 3 f of x plus 1 plus 3 f of x plus 2 minus f of x plus, this was just f of x now, f of x. This was just f of x at last. Oh, it was f of x plus 3 only, sorry. Plus 3. Right, so this will be the answer to this question. Now what you have to do is we have to compare. If I just try comparing this with what I have derived, do they match? The coefficient of f of x plus 1 is plus 3. What is the coefficient I am getting in this case? Minus 3. You see here, the coefficient I am getting is minus 3, whereas the coefficient I should be getting is plus 3, which means that they are not the same thing, right? So A is incorrect. A is incorrect. I need to just go ahead and find something which is the reverse of A, right? I need to reverse the sign in these two middle cases. Then you can just try with B, try with C, try with D. Just put these values out. I'm leaving it to you. When you will be doing this, you will find that I think with C, it was matching completely. When you will go ahead and put it with C, you will get exactly the same answer here. And you must be verifying it for 2 also. Both should be verified. So I think that for B and D, the second one itself was not holding. Right? So when you will go ahead and you will follow this process, you will notice that only option C is satisfying the two equations. So answer would be C. Right, beta? Okay, thank you.